Here we are now is looking simply at a single wave pulse. As you'll notice, we can start pulsing or putting these pulses of energy through the medium of this slinky that we have in front of us. A single pulse of energy that can flow through the entire slinky from one end to the other, and it simply stops. Notice the direction, notice the height of the pulse as it travels through the slinky. And how there's the original bottom of the slinky where it originally was, and then how the height of the pulse then gets up almost to that shadowed region.
There's a wave building up in the Arctic, and it's headed all around the
First section analyzes the two key types of waves. One's going to be the longitudinal and the other the transverse. Notice how when these pulses of waves are going, that the actual direction of propagation is perpendicular to the direction of the energy or the pulse. And so the slinky actually moves upward with the pulse and the energy. This is known as the transverse wave. Let's look at it a little differently, looking at what's known as a longitudinal wave. In this case, the point of propagation and the energy pulse are in the same direction. It's a bit tricky to see. There's a subtlety, but you can see how this energy pulse goes through the slinky and bounces back and forth. But again, it's the in direction of the propagation of the wave that the pulse is traveling.
Everything is connected in this piece of time and space that we share.
The second part of the lab is looking at a principle known as superposition. As you'll notice, the pulses are going and traveling back and forth along the wave, but what happens when two meet from both opposite ends in the middle? As you'll notice, one is coming from the top while one is coming from the bottom of the slinky. They keep the same pulses going, and the energy continues in both directions. But notice, if you can, at exactly the moment that they meet. The notion of superposition is that the energies actually cancel each other out. The bottom with the top, and thus at the very moment of meeting, it comes back to the neutral or perfectly flat slinky.
There's a wave building up in the Arctic, and it's headed all around the world.
At the moment of meeting, if you can notice the height going down, is that it almost doubles the height of the single individual pulses. And so again, the superposition is an adding or subtracting of the two pulses at the point of contact, and then the continuation of the pulses afterward.
Through the mirror of my mind, time after time, I see a reflection of you and me.
The third step is to look at a single pulse hitting a rigid boundary. And what happens is what's known as the principle of a reflection. So notice how the pulse coming from the bottom hits the rigid boundary on the left-hand side. What happens, but it reflects, and by bouncing back on the top side, or the upward motion. So a true reflection is the pulse comes in from the bottom, hits the rigid boundary, and reflects back, but as in a reflection in light or on a lake, it's on the opposite, or gives a mirror image in a sense. The pulse hitting the rigid boundary, the reflection, and the upward coming back.
Love you and me, reflections of the way life used to be, reflections of the love you took from me. Oh, I'm all alone now. No love.
A third phenomenon we're going to look at with the transverse wave is when superposition and reflection take place simultaneously. The constructive and destructive forces start to happen. In this case, it's what's known as a single node, where the destructive forces are happening at the two ends. If we were to speed up the pulse and the propagation, notice how there's destruction happening also in the middle. This is known as the second node, or the second frequency. The node and the nodes are those points where the destruction is happening, that the wave pulse is actually stopped. And the two antinodes, the two crests, are on the two ends. Now, as more and more energy is added, could you build up to a second node, a third, fourth? Imagine the possibilities. Higher and higher energies, creating more and more nodes and antinodes. Again, these are constructive and destructive forces with the combination of the reflection and the superpositioning happening simultaneously. What are the different variables that we can adjust when looking at the waves? Well, one way is we can change the tension of our slinky in this case. As you can see, it's a very low tension, and you notice how slowly the wave pulse is traveling through this particular tension of the slinky. What if we were to change that tension? As you can see, it's getting tighter and tighter. The slinky is the rings are getting further and further apart, and as the pulse is sent, look at how quickly that pulse is traveling through the median. In a sense, it's the notion of changing the medium, or the tension in this case of the slinky, but if the medium is changed from a high tension or more high dense medium to less dense, notice how the speed changes. Less dense, less tense is much slower. High density, higher tension is much quicker. Let's take this transfer of mediums to the extreme. When we have two different slinkies, one of a much higher tension and much smaller rings, entering our bigger slinky with much bigger rings. Notice how the pulse of the smaller slinky, the higher tension, enters into the bigger slinky. This is the principle known as refraction, going from one medium of a higher tension to a lower medium, to a lower tension medium. Notice how the pulse is starting going up as it enters the bigger slinky. If we were to reverse this, watch how the pulse comes from the bigger slinky to the left and enters into the lower one. The pulse on the left is coming from the top, but notice how as it enters the darker, smaller slinky, the pulse is on the bottom. Thus it has reversed the pulse. It is a reflection, but refraction is happening as well.